Good morning, everyone. Well, this is the final late-breaking news out of three, and the best one always comes the last. Now, my name is Tetsuo Yasaka. I'm a member of the IF Bureau in charge of technical activities, and I'm extremely delighted to introduce to you Mr. Barry Matsumori, who is my long-time friend. I've known him for over 30 years, I think.
We both grew older.
And, well, at the time I knew him, we were both engaged in communication satellite development, and he was a representative from Space Systems L'Oreal in the United States. And he stayed quite some time in Tokyo, and we got together. And later on, he moved on to launch a business with General Dynamics, which is a surprise to me. And after that, I heard that he again shifted to the telecommunication area with Qualcomm. Is that right? That is the portion I know. And we lost contact totally for 15 years or so. And I met him the other day here in Naples. It's a surprise. And he is now the senior vice president of SpaceX, and he's going to tell us what is going on in his company. And I am totally ignorant what is going on in SpaceX and what he's doing over there. So I'm very much expecting to hear what he has to say. So Barry, the floor is yours.
So I'm a character, not too much convention, so I'm not going to be standing behind this thing. And you'll probably see me moving around because I'm a little bit nervous from time to time. But what I want to do is, first of all, good morning and thanks for showing up so early. My expectation was 4 people, and this is a whole lot more than 4, so I'm very happy. What I'll do is I'll spend a few minutes talking about SpaceX as a company, not very much, but I just want to make sure that everyone has kind of a common baseline of who SpaceX is. And then from there, go on to talk about the last ISS mission that we had. I actually want to keep this a little informal. If you do, in fact, have a question in between, if you're not shy, go ahead and raise your hand, and I'll take questions. But otherwise, we'll move through this, okay? So a little bit about SpaceX and the company itself. We're based in California, in Hawthorne, California. It's a suburb of Los Angeles near LAX. We're 10 years old now. We just celebrated our birthday not that long ago. And so we're feeling, in fact, a little bit older relative to most aerospace companies. We're pretty young, but for us, we've come a long way since our early days of initial developments. We have about 1,800 employees. It's actually larger than that. We've been growing pretty steadily, about 200 employees a year or so. So for us, that's growing fairly quickly. And I'll point to this building here on the left. That's our headquarters in Los Angeles. They used to make 747 fuselages in there. So if that gives you a feel for how big the building is, it's fairly large. And in there, you'll see that up front, this first, if you will, 10% of the building is offices. 3 floors of offices, 100% cubicles. And I'll tell you, after the last 20 years of being in private office, going back to a cubicle was a little bit of an adjustment. But nevertheless, what it supports is very open communications. So across the board, the CEO, as well as everyone else in the company is in the cubicle. The back part of this entire building is all manufacturing. And what's very nice is going from the office area, development area, into production is very transparent. And under that roof, what you're going to find is tank production, engine production, avionics, bipropellant bottles, Dragon capsules, thermal insulation, composite production. If you're getting a picture here, one of the things that SpaceX does is we're highly vertically integrated. So there's very little that we outsource, and it's all pretty much produced under this property right here. Okay, so that's our headquarters in Hawthorne plant, at the Hawthorne plant. We also have in Central Texas a place called McGregor, test firing for all our engines. We fire 100% of our engines multiple times. And you need a place with a lot of empty area to test fire engines because it gets a little bit noisy. So Central Texas is a great place for this. And we truck all of our rockets from here over to Central Texas, test fire them, and then from there we'll transport them either to Cape Canaveral Air Force Station in Florida or to Vandenberg Air Force Base to Complex 4, 4 West, and launch on either of those sites. What's interesting is we are also contemplating an additional site that will be a private site. And the reason is that we want to ensure we have plenty of launch capacity. In this particular case, it's going to be for geostationary launches. Quick business overview on SpaceX. It's a privately owned company. It's been private since it was founded by Elon Musk back in 2002. And we have a little bit of a mix of not only the management staff, but also the staff in general. We have people that are certainly from aerospace, and then we have a mixture of people that are from different industries. I myself, for the last 20 years, have been in mobile telecom, primarily with Qualcomm. A good example is the head of production. The head of production came from BMW Mini. And the reason is that we want to do high rate production, not necessarily aerospace level production. We have about $4 billion in backlog orders, so we're doing reasonably well. Been profitable since 2007. And if you look at this, the distribution shows that most of our business is actually commercial. We certainly are very happy with the government business we have, particularly with NASA, but in fact, a large part of our business is commercial. And then the last thing I'll point to is we try to be, if you will, kind of an internet company, very fast moving. And one of the things that we do that's a little bit different in the industry is all our specs are online, and certainly our pricing is online. So if you do have some spare $1 million, we'll definitely sell you a bunch. Okay, flight history. We did start with an earlier rocket called the Falcon 1. I'll not include that in this lineup, but I do want to talk about Falcon 9 flight history. So we've had 3 successful flights, the most recent being back on May 22nd. And what's interesting and unique is we do have, it's Falcon 9 for a reason, there's 9 engines. And so what you're really talking about is not only 3 flights, but 27 engine firings, and successful engine firings to place the Dragon capsule in orbit. So it's been a pretty good flight history for the Falcon 9. On top of that, we've had 2 missions where we've taken the Dragon capsule and either into orbit or in the last mission to space station, been successful with that. As far as product line, so our current offering is the Falcon 9 with the Dragon capsule. That's on the left-hand side here. We also are doing a Falcon 9 with a 5.2 meter fairing. So that's for various satellites into different either LEO or geostationary orbit. And then in development is something called the Falcon Heavy. And this is essentially taking 3 Falcon 9s and strapping them together. We could have called it a Falcon 27, but it actually doesn't sound too sexy. So we just called it Falcon Heavy. And then lastly, we have the Dragon capsule, which we'll talk a little bit more about later. Okay. A couple more slides that talk about the vehicles, and then we'll get to the mission. So the Falcon 9 is the base launch vehicle that we're using, and it's a 2-stage vehicle. For a number of reasons, we decided to keep it minimized to 2 stages, mainly for reliability and simplicity. And as I said before, first stage has 9 engines. Second stage has 1 engine. What's interesting is they're both called Merlin 1Ds, and it's because the base engine is the same. The only thing we've done on the Merlin 1D vac, is we've extended the nozzle for operation in space. And there's a number of things that we've done in the design of the vehicle that we've done for reliability purposes. We have a little bit of a reputation in the industry of being, if you will, very competitive in our offering. And how do we achieve that? We achieve that by designing for high reliability and low cost production. But what we can't sacrifice in any of this is the reliability of the design. So we do a number of things, and I cite a few here. One of the things that we do is when we fire, we hold on pad. So we fire the engines, hold on pad, the computer will go through, test all of the telemetry with the engines and the rocket itself to ensure that it's ready for flight, and then release. So that's one of the features that we think is pretty important. I can talk about May 19th, that in fact we practiced that because we had a launch, T-3, the rockets fired, and we shut down the engines because we found one engine that was in fact out of tolerance. So that system works very well for us. We have engine out capability, so in flight, at launch or in flight, if we lose an engine, we can still maintain the mission because of the way we designed the vehicle. Oh, I don't want to go through this too extensively. Fault-tolerant avionics, so the design of the avionics, we've done really commercial off-the-shelf parts and try to keep it so that it's a much simpler design, less expense, yet it has fault-tolerant capability. And the last thing is kind of interesting. Since day one, we've designed this vehicle for all our vehicles for man rating. And so you see safety factors involved that are man rating factors. If you look here, this is the Dragon capsule, and you see a window there. First flight, second flight, there's been no humans involved. And so people have asked us, why do you have a window? There's nobody watching outside. And the answer is because we've always had in mind to put man in our capsules. All right. On the Dragon capsule itself, it's got 2 parts to it. The front is the Dragon capsule, and then the back we call the trunk. So this is a pressurized section in here, unpressurized section in here, and then on top of that we've got two 4-panel solar arrays on each side that deploy immediately after separation from the second stage. A number of other features. It's got heat shields around it. What's kind of interesting is this heat shield, again, we're highly vertically integrated. We also produce that ourselves inside the Hawthorne plant. Let's see, dimension-wise, you can see some figures here. What's kind of notable about the Dragon when it's flying is when it has a solar array deployed, it's very noticeable. I mean, in space, you're not really flying per se. It's not an aerodynamic event, but it does look like it's flying. Dragon is, so it was one of those mythical things that we wanted to have. If you ask why did we name it Falcon, that's also a good question because Falcon is in Millennium Falcon from Star Wars, so we kind of pick our name somewhat humorously. The volume inside the Dragon is 12 cubic meters, so it's pretty big. If you look inside, for cargo, it's pretty spacious. Certainly for astronauts, it's very spacious. And then there's some communication systems that are interesting because these are designed by SpaceX. And so we have what's called the Cuckoo, the COTS UHF comm unit. And so there's one sitting inside ISS and one sitting inside Dragon. And that's a means for the two to communicate with each other. And then from there, I'll move on. The last slide that's kind of just generally covers SpaceX and our products is you want to characterize, or if one wants to characterize what is SpaceX about, there's a lot of vision in the place that's driven a lot by this gentleman right here, Elon Musk. He's the founder, and CEO, and as a side note, he's also the founder and CEO of Tesla Motors. So he's a little bit of a busy guy, but he clearly drives where we're going and how quickly we're moving to develop products at SpaceX. This is Charlie Bolden. This was after the last mission, and they had a session with the employees just kind of thanking everybody for the work they did. And if you look at the things that characterize what we're doing, we certainly have innovation involved, not only in technology, but also in things like production. Attention to detail is a pretty big thing at SpaceX. Across the board, from whether it's an email and being careful about how you spell your emails, because typos inside SpaceX are actually a no-no, to how we produce and manufacture a Dragon capsule. We spend a lot of time on details. Oops, that's part of the culture. Execution, definitely getting things done. I mean, people look at the timelines that we get development done, and it's a lot about being driven for execution. And the last is probably the most important, and that's passion. There's hardly an employee that's at SpaceX that isn't there for one reason, and that's space. They can say, yes, I'm getting compensated, but they're very passionate about space itself. Okay, so what I want to do is talk a little bit about the NASA activities that we have, and I can't reiterate enough how much gratitude SpaceX has to NASA and the cooperation we've had with them. So the first thing is the COTS program, and it's not commercial off the shelf. In fact, it's the Commercial Orbital Transportation Services Program. The COTS program has been the basis for us doing these missions, these Dragon missions. And the goal is cited up there is to be able to take cargo not only to ISS, but also to bring it back for us. There are two companies funded, Orbital Sciences and SpaceX. And in our case, our offering, as you saw earlier, is the Falcon 9 launch vehicle and the Dragon capsule. And what is unique about Dragon is we not only take cargo up, we can bring it back to Earth. So in the last mission, we not only brought various assembly goods, but things like there's some experiments that we were able to bring back from space station. So it's quite a useful function. And the contract involved first 3 demonstration flights, of which we had 40-odd milestones that we had to complete and complete successfully. And then once those are completed, then we'll go and do 12 commercial resupply missions. So we've completed those 3 demonstration flights. We're actually starting our resupply missions. I'll talk more about that later. So the first mission was a orbital flight, and that was back in 2010 on December 8th. And so this is where SpaceX became the first company to take, a private company to take a capsule and orbit the Earth and recover. And anyway, you can see the orbits we went through, and then recovery of the Dragon capsule itself. We do recovery off the coast of California, off the Baja coast. The latest mission was what we call COTS 2 Plus. I'll talk more about that later, but it was a combined mission of COTS 2 and COTS 3. And in this case, there was 2 parts. One was to actually do a flyby to ISS, and the second part was to actually berth the space station. This is where I'm going to spend more time in later slides talking about what is it that we do. And then the other program that we're actively involved in is there is a recent award of this CC-8 ICAP program. This is for commercial crew for taking astronauts to space station. And we were one of the people awarded to be down-selected. There's still further exercises to down-select the winner, but ourselves, Boeing, and Sierra Nevada Corporation are down-selected. So this should be an interesting competition to provide this service. For us, we've always been interested in doing not only cargo service but manned service. So it's a very much a complement of the work that we want to do. I'll point out what you're seeing on this picture here is a mock-up. We have actually a mock-up in our factory in Hawthorne of the capsule that we'll use for commercial crew and how we'll fit 7 astronauts in it. So we've got it outfitted where we have 4 seats on the top deck and 3 seats on the bottom deck with 2 windows actually. So this time astronauts can actually look at it. Okay, I'll next spend most of the time talking about the COTS 2+ mission. So with that, could you run the video? This is a quick summary of the mission itself.
Initiating the capture of the Dragon. Standing by. Capture is confirmed.
A huge sensation. Looks like we got us a Dragon by the tail.
I spent quite a bit of time poking around in here this morning, just looking at the engineering and the layout, and I'm very pleased. So flying up in a human-rated Dragon is not going to be an issue.
There's a lot of things I can point out on video. You notice a lot of employees. That was at 2 a.m. in the morning in Hawthorne, California. So a lot of enthusiastic employees about what we're doing. The other thing is that this is a great video. I really enjoy it. But in a sense, it doesn't give a feeling for just how complex that mission was, the challenges that we had to get that thing to space station. It was a pretty darn good mission. There's little anomalies you run into all along. And when it's your first mission to space station, everybody, NASA, SpaceX, we do not want to make mistakes. So every time some small anomaly, doesn't matter what the size is, people get extremely nervous and what do you do next? Because the absolute last thing you do is you do something that could possibly damage space station. So I'm going to spend a few slides talking about a little bit more detail on the mission. Okay? What I'll do next is just a chronology. So first was the COTS 2 mission, okay? And the launch was actually on May 22nd. I talked earlier about a launch attempt on May 19th. And this mission is challenging because we have an instantaneous window. We have a 1-second window. So we either go up that day, or in this particular case, we had 3 days, and you had to wait 3 days, and then have a potential window. If you don't make that one, you have to wait another 3 days, make that window. So we either made the launch or you didn't. On May 19th, we did not. As much as I'm happy that we aborted that mission to check out the engine that we found in off-normal condition, Having an engine light up, this is at 4:45 a.m., having the engines light up, the sky was dark. Light up the entire sky, about 3 seconds worth of burn, and then it gets dark out is truly disappointing. So that said, on the 22nd we did go out. So we had the Falcon 9 launch on the 22nd. It sort of dragging into its orbit. Actually, that insertion was quite within nominal, so that was very good. Then the thing that Dragon did is it spent the rest of the first day doing system checkout of all the systems. And anybody that's done space operations know you have a set procedure that you go through, and you're doing this very carefully to ensure the operation, when it really counts, is going to work. So that's where we spent day one. Day two, this is where Dragon starts doing a number of maneuvers to come close to space station, not extremely close, but close to space station, and determine whether or not it's going to be safe to actually approach closer. So we did a number of height adjustment burns with co-elliptical orbits around space station, either in front or in back. Again, just to go and get comfortable with what can Dragon do in some distant proximity of space station. On the third day, we got within 1.6 miles of space station and did maneuvers around there. In particular, we practiced communications with the Cuckoo unit with space station and with the astronauts inside space station being able to communicate and control Dragon. In this particular case, we had some strobe lights on Dragon, and it can sound a little trivial, but all we did is we had the astronauts turn on the strobe lights, turn them off, make sure that, in fact, there was control. And then we did burns away from space station, and that was the COTS 2 objectives, and we completed them. So the next graphic is a kind of a depiction of what we did. We flew phased in close, and then did height adjust burns to get within 1.6 miles, and then did some orbits around space station, either in front or in back, again to control, as well as communications with the crew inside space station. All right, so now we go to day 4, and we're doing more height adjust burns in small increments to steadily come closer and closer to space station. This entire time, this is a coordination between NASA and SpaceX, because this is a commercial contract. We are doing design, development, all this, but the one thing that NASA has rights to is, can you approach? And if it's a go, no go, and they can say no go, and we have to back off. That's one thing that they very much need to control. So with that, we did these height adjust burns with approvals along the way, and then the laser guidance system, we had to do a demonstration because it's key in order to berth with space station. And another key is there's a command that the astronauts can, one of the commands they have for control of Dragon is if they see any condition that they're not comfortable with, they can tell Dragon to basically go away, to retreat. That's a key command. So we did incremental approaches up to 30 meters. From there, we did some more testing. And then finally, on day 4, we approached within 10 meters, and that's when the robotic arm will grapple us and then berth us to the space station, the Dragon capsule to the space station. The 5th day, they were done. Actually, it was a pretty long day. On the 5th day, they opened up the hatch, inspected the environment, make sure that it was safe for astronauts to actually go inside. And then, really, that's all that was. Don Pettit made an interesting comment when he came inside the Dragon. He said, "It smells like a new car." It was kind of an interesting comment. On the 6th day, we actually transferred cargo. The mission was supposed to last a little bit longer than the 10 days, but they got cargo transferred and decided, let's go ahead and let Dragon go and release it. So they released Dragon, brought it out on the robotic arm, and then did a bunch of departure burns, did the deorbit burn, and then as you saw in the video, deorbited close to, landed close to the Baja coast. We were within 0.8 miles of the target that we wanted to be on, so pretty darn close considering how far off range you could be. So that is a summary of the COTS 3, if you will, original COTS 3 mission, and it's, you get a feel for a little bit more complexity of what happened. Here, another graphical depiction. You can see that we do all of these height adjust burns to get closer and closer. And in fact, within this keep out sphere, there were a number of burns that we did in order to get approval to get closer and closer to the space station and burn. So each one of these operations takes a lot of time and communications between NASA and our Mission Control Center. As a side note, we have a Mission Control Center in Hawthorne, California, and that is communicating with NASA as well as with other individuals to ensure this mission is successful. So, as far as the success of the COTS 2+ mission, there's not much to say other than all the success criteria that were established, we passed. Were there some small anomalies that occurred along the way? You bet. Did we? I mean, there was. You can see if you were watching the mission, we were within approach, 30-meter approach, and at one point we actually stopped and backed off, and that was because we had to recalibrate the LiDAR. And so you can imagine we're starting to approach, and then all of a sudden people go, "Wait a minute, the guidance system isn't working. Stop and go back, troubleshoot as quickly as possible." So a lot of stress during that particular phase. We got it recalibrated and then approached, and it worked fine. What's next? So we have now approval for executing on the next 12 true commercial missions to take cargo to space station. And as it were, this Sunday is the launch of CRS-1, the first true commercial activity. And so we're anxiously waiting for that. In fact, a joke earlier, myself and Robert Feuerbach are here, and we're probably the two only guys that don't have anything directly to do with that mission. Otherwise, everybody else is working the mission. And then we have a next resupply mission set for January of 2013. This is the photo here, by the way, is a static fire we did on the 28th in Florida. So this is the Dragon capsule, and we actually fired the engines. This is one of our test sequences to ensure that the stage is working properly. And with that, we definitely have a lot more in mind for missions. This happens to be a hotel in space that we have an agreement with Bigelow Aerospace to work with them. So hopefully we're taking even more passengers to space. That's it. Thank you very much.
Thank you, Barry. Now it's time for questions. Raise your hand and say your name and affiliation, please.
Hi, I'm Abhijit. I'm from the University of Sydney. You spoke about the commercial crew program that you got from NASA. When are you looking to actually develop that capability? What kind of timeline are we looking at before we can start sending people to the ISS?
I'm going to be a little careful on the answer because those discussions are taking place, but nominally it's going to be in the 2016-2017 timeframe, potentially sooner.
Hello, Sinje Steffen from the German Space Operations Center. I was wondering, your operators in California, are these the people, the engineers who actually built Dragon, or are these especially operators just?
It's the answer is it's a mix, but many of them actually built Dragon personally. I think I mentioned up there, we're 1,800 people. What's kind of an interesting statistic about the company is I think our median age is somewhere around 32, 33 years old. So we have a lot of young engineers, but really bright guys. What we do, though, is we have very experienced technicians in the factory. And so if you go to our Mission Control Center, you'll see folks that have experience in mission operations, but you'll also see people that grew up with the company and personally designed some of the equipment, either Dragon or Falcon.
Yeah, Jean-Paul Berthias, French Space Agency. First, let me congratulate you for this wonderful achievement. We've been there and we know how difficult it is. Now, right now, Dragon is only birthing and it's been captured by the robotic arm. For crew, I assume that you'll be doing actual docking. When do you plan to transition to docking?
I don't know the answer to that, and I don't think anybody does. That's a kind of ongoing discussion we'll have with NASA. But I'd say right now there's no clear answer.
Okay.
I'd like to know
Your name and
my name is Harunori Nagata from Hokkaido University, and I'd like to know some detail about the maneuvering when you approach to the ISS, especially for the direction of the throttling.
I'm sorry, the direction of the...
The rocket throttling. Throttling. To approach from the down, lower to approach the ISS. And I'd like to know the detail about the control, especially throttling.
Yes, I'm not. I don't 100% understand the question, but certainly the guidance software is software that SpaceX has developed, and additive control system developed by SpaceX. Are you actually asking about that?
No.
To which direction you put your thrust on to get to the station?
Yeah, you know what? I probably don't know that answer, and on top of that, I may not be able to give the answer anyway.
Thank you. Down. Yeah, in the middle.
David Claire, again, congratulations. Small questions. What type of requirements did you have with regard to ISS safety, with regard to redundancies and segregated chains?
So your question is, what kind of requirements were there for vehicle design and redundancy in order for NASA to approve that we approach ISS? Is that your question? The design of Dragon capsule itself does meet man rating requirements. So that part NASA was comfortable with. I think it's not so much what design requirements were there as opposed to how much did we work in tandem with NASA on simulations, on mission simulations, on testing. That's probably much more important than the design requirements. They had a look at how we designed Dragon. They looked at things like avionics redundancy systems. But I think what's more important is the simulations, and did they have confidence that we covered all the potential scenarios that Dragon can encounter and be able to either maneuver out or back away or do whatever action to cover those scenarios. So I'd say we spent on the COTS 2+ mission, we probably spent 4 months of solid simulations with NASA every day. If you walked into the plant, we have a Mission Control Center. It's a very large format display, and you knew when simulations were going on. So that was probably the most important factor. The design part, I'd say, is almost secondary.
Okay, thank you. Okay, we'll have 2 more. Okay.
Stu Pirard, Bologna Space for Belgium. I have a question concerning your commercial flights to GTO. Yes. And when will the first flight happen? And which payload and which different between the Falcon 9 for GTO and Falcon 9 with Dragon?
It's a good thing you kept it to 3. My buffer was about to overflow. So let's see. The first commercial flight is to GTO would be in May of next year. Okay, and that will be with SES. And maybe you did overflow my buffer. And the Falcon 9 that's used for, I think it was Dragon missions versus commercial satellite missions. It's the same Dragon. We don't have a separate product. Was that your question? I'm sorry? No, they are not. No, we have. It's the same rocket. Another question? You actually have to get organized.
Well, there was a question whether the engine is different, but Barry says no difference in the engines.
Clyde Simpson, our international magazine in the UK. You mentioned the commercial launch site potential. Could you tell us where you might be looking at to site that and the timescale for it, please?
Okay. We've been looking at several sites across the U.S., primarily in continental U.S. It's public information that we've been looking at a site in South Texas. Certainly, we've been looking at sites in Florida. There are potential flight sites in some other places, but those are probably the 2 principals. Time frame wise, it's difficult to tell, and the reason is the one unpredictable factor is environmental approval, and it could take a year, it could take 2 years, it could take 4 years. So it's difficult to say when we'll be online. Certainly, anyway, I'll leave it at that. But we have definitely a couple of sites in the U.S. That we're looking at.
Okay, thank you very much. I have to say that we have to finish this session. I'm sure Barry will have some time around here, so we can have personal questions to him. And we know we have technical sessions and General Assembly from 9 o'clock, so we'll have to say, I'll have to say thank you very much for coming to this occasion, and hope you have a nice trip back. Thank you.